Hey everyone. All right, let's take a look at this. Question 1. A square cake pan measures 30 centimeters on each side and is 5 centimeters deep. Cody wants to coat the inside of the pan with non-stick oil. If a single can of non-stick oil covers an area of 400,000 centimeters squared, how many pans can be coated with a single can? Okay, so I've drawn this little picture here of what this cake pan looks like. It's 30 by 30, so it's a square, and it's 5 centimeters deep, okay? And he wants to coat the inside, okay? So he wants to coat that side of the pan, this side of the pan, the bottom, and then these two sides here, sort of this one here on the inside of this outside edge here, and then the side on the inside of this outside edge. So essentially 4 rectangles and 1 square on the bottom, okay? And the square's dimensions are 30 by 30, okay? So he has 4 rectangles. Let me write this down. 4 rectangles and 1 square. And the area for all these is just the horizontal by the vertical, okay? So the rectangles are 5 centimeters by 30, and there are 4 of them. So I'm going to multiply, what it is for 1 by 4 to get the other ones. And then the square on the bottom is simply 30 by 30, okay? So the surface area of the inside edges, the 4 edges, is going to be 150 times 4, which gives us 600 centimeters squared. And then the bottom is 30 by 30, which is 900 centimeters squared. Okay, so for him to coat the inside edges of this cake pan, he's going to have to use 1,500 centimeters squared. And that's how much of the surface area on the inside of the pan here where he wants to spray the non-stick oil. Okay, but that's not what the question's asking, but we're almost there. It says, if a single can of non-stick oil covers this amount, 400,000 centimeters squared, then how many pans can be coated with 1 single can of this stuff? So if we know it's going to take 1,500 for 1 pan, then how many can fit in within this amount of oil? So it's simply this divided by that. So 400,000 divided by 1,500 gives us 200 and, so let's see here, let me write this down. So 400,000 divided by 1,500 is 266.6 repeating. So in total, can't quite coat 267 of them. It's just a little bit less. So we'll say confidently he can do 266 pans. So 266 pans. There we go. And that's our answer for that one. Okay, let's take a look at this one with the tennis balls here. All right, each tennis ball has a diameter of 7 centimeters. Calculate the amount of material needed to make a can that holds 3 tennis balls. So the diameter is 7 centimeters, okay? So these distances from one side of the ball to the other are all 7 centimeters. Okay, you with me? And we're making a can here. So basically it's a cylinder, obviously. And we're going to need a top and a bottom and then the middle part. Okay? So what this told us, and I'll draw one more diameter here. So from the top and bottom, the diameter is going to be 7 centimeters across the top and the bottom. okay? And the height of this can to fit 3 of these tennis balls, because each ball has a 7 centimeter diameter, that means one of them is 7 centimeters tall, 2 of them is 14, and 3 of them is 21 centimeters, okay? So essentially what we've got here is a cylinder. Let me just mark that off. There is a cylinder that is 21 centimeters tall, and the diameter is 7 centimeters. So we worked on some stuff like this earlier this week, okay, of what it would take to find the surface area of a cylinder with a diameter of 7 and a height of 21 centimeters. So I'm not going to go through that on here because you can look back at one of my other videos, but that's kind of the information we dissected from this explanation of what they're, what the question's asking, as well as this picture. And hopefully now that I've drawn it on here for you, it makes a little bit more sense as to this is the cylinder we're dealing with. So the amount of material needed to make it will be the surface area of this cylinder here. And the answer is 538.51, and we're talking centimeters here, centimeters squared, okay? So question 1, the answer was 266 pans. Question 2, the answer is 538.51 centimeters squared. And the last one here, number 3, says, if the edge length of a cube is doubled, find the ratio of the old surface area to the new surface area. So a ratio is a comparison of things. So someone might be twice as big as someone else, so then the ratio of them, of the people we're talking about, would be 2 to 1, right? Or something might be half as big as the other thing, and then we can figure out the ratios that way. So basically all it's saying is, if we know the edge length of a particular cube is doubled, what is the ratio of the old to the new in terms of the surface area? So questions like this, it's tricky. It's like, well, I don't know. They didn't give me any numbers. So why don't we just put some in? So let's say we've got a cube, okay? The original cube. So I'm going to draw a cube here, and its dimensions are going to be 3 by 3 by 3, okay? Each side is 3 centimeters. So that's 3 centimeters. This is 3 centimeters, and this is 3 centimeters. So what would the surface area of this cube be? Okay, so there's 6 sides, and they're all squares, and they're all 3 by 3. So the surface area is going to be the surface area of one side, this blue side here, is going to be 3 times 3, which is 9, right? So one side length is 9 centimeters squared. But we know on a cube there are 6 of them. So the surface area of this particular cube is 54 centimeters squared. Okay? All right, now we have a kind of a baseline image to go on here. So if the edge length of a cube is doubled, so it's no longer 3, it's 6, we're going to have a cube that looks twice as big, essentially. So we're going to have one that looks like this. Okay? And now all the side lengths are 6 centimeters. We've doubled them. And we got that because the question told us so. So what's the area of this side going to be? It's a square, so the horizontal times the vertical gives us 36 centimeters squared. And just like any other cube, there are 6 of them. So we've doubled the side length. We've got one side equaling 36 centimeters squared. And there's 6 of them, so the total surface area is going to be 216 centimeters squared. Okay, so we're going to deal with 54, and we're going to deal with 216. Now the question asks for the ratio. So what's the ratio going to be between the old surface area and the new surface area. Okay, so I'm just going to draw that down here in the corner. So the old one was 54, and a ratio is with those two little dots. So then we have 216. So in lowest terms, this is going to give us 1 to 4. So in other words, if we take a cube, okay, with side lengths 3 centimeters all the way around, its surface area is 54. Now, if we double the side length from 3 centimeters to 6 centimeters, the surface area of this cube is now 216. So it went from 54 to 216. So you would think that the surface area would just double. If I double the side length, 3 to 6, well then it just must be twice that, 108. But we can see clearly here that because we're dealing with area and we're multiplying numbers by themselves, we're not simply just multiplying everything by 2, the new surface area is actually 4 times as big as the original one. And the reason that is because when you double something, when we're talking about area, you're essentially multiplying it by, you're squaring it. So you're not just doubling something, timesing it by 2, you're taking 2 and you're squaring it. And we know that 2 squared is 4. So that's why it's 4 times as big as that. So our answer is 1 to 4. Okay, hopefully that helped. Don't forget to email me if you have any questions. Bye for now.